This is my code review for project CS340, the Animal Shelter Management System. So basically it's a client-server project that interacts with MongoDB database to manage animal records. In this review, I'll analyze my code, go down the CS499 code review checklist, which includes discussing structure, documentation, variables. I don't have any arithmetic operations on this one, so that'll be left out, but I do have loops and branches, and I'll also be discussing the defensive programming as well as the enhancements that I plan to have for the end of this project. Alright, so in reviewing my code for project 2, I found out the structure of the application met the design requirements and correctly implemented the intended functionality. The dashboard successfully connects to the Mongo database. Here we import the CRUD module to interact with the MongoDB right here. And then I list my credentials right here. And then when you want to instantiate the animal shelter class for database operations, that's where the shelter variable comes in with the animal shelter class from the animal shelter.py file, where it grabs my username and my password so it can log in. It also retrieves data using the CRUD class or the animal shelter class. And here we have different functions within that class. We have here we go connect the variables, replace the variable values. So here's our Mongo client with the user, the password, the host, the port, and the database that we're going to go into. The auth source equals admin means we're going to be logging in as an admin user. We have the connection. If the connection fails, it will print out failed to connect to MongoDB. That way we know that it actually did not connect. And then we have our create function, which creates a new document within the database. You see here. Then we have the read portion of the class, which is this read function. It retrieves documents from animal collections based on the query. The parameter query dictionary specifying the search filter. So basically we could filter out what type of animal we want to search. So here's a couple filters. So we could look for a water-based dog, or mountain, or disaster rescue, different breeds, the sex, the age minimum or the age max, which this is in dog years, obviously. I don't think a human can live up to 156 years, or a dog can. And then from there, I believe the code follows the standard Python formatting practices, and the layout is organized using dash components in a consistent and readable structure. Like I said, I have my create, read, update, delete. I feel like that would just be very easy for if somebody had to jump back into this. They could easily understand the CRUD functions and find them very easily, which is important. And then in our dashboard, I laid it out HTML divs to lay out the graphs and the maps to find these dogs or animals. Some of them are cats, I believe, if I remember that correctly from this project. I think my documentation was pretty good throughout the code. I feel like my comments were very clear. The animal shelter class includes doc strings that explain the purpose of each CRUD function pretty easily. Here's the first one, for the CRUD, for the create function. Then the read function, I feel like I did it pretty well. Update and then delete, kind of formatting them the same. So it's a little bit easier to read, a little bit easier to understand what each function does. Um, the variables used, I feel, in this project are named clearly and represent their purpose well. Again, create creates a new file, read. If you want to gain access to some information about a dog, you could do that. Update, you could obviously update a current file or one of the dogs, or you can even add. And then delete, if you need to delete a certain file or a certain rescue dog, then you could use that function. So I believe the variables are used pretty well. Even in the dashboard, this is my, let's see here, update maps. I believe that's done pretty well. It's the update map is for when you click on a certain dog in a list, it will show you exactly where on the map the dog is located, see how far it is from you. So I believe my variables are used pretty well throughout the project, named clearly, and represent their purpose pretty well. There was no arithmetic, like I said, for this project. There's no math really involved. For this one, the use of loops and branching, though, I believe I did a pretty good job. I would say that's probably one of my biggest weaknesses, but I feel for this project I did pretty well in using the loops and branching logic in the application. The filtering process handles all possible drop-down selections, including the reset. Let's see here. For example, the update data table in Pi. I use the if select filter is none or select a filter equals reset. Basically resetting the entire map or the graph of animals that you're trying to look for. Like for example, you could look for a Labrador Retriever mix. You can look for an Alaskan Malamute, an Old English Sheepdog. If you're looking for a disaster dog, you can look for a Doberman Pinscher, German Shepherd, Golden Retrievers, Bloodhound Rottweiler. If you want to search for a mountain dog, use German Shepherd again. This time you have an Alaskan Malamute. Water rescue, you can look for a Labrador Retriever mix, a Chesapeake Bay Retriever, Newfoundland. There's a variety of options. And from a defensive programming standpoint, both the dashboard, I believe, and the CRUD class validate inputs before performing operations. For example, the create method has, checks that the data is a dictionary and verifies that a matching document does not already exist before inserting. So basically right here, that's where you get that one. Check for existing document, looking pair, and if the document already exists, it will not insert it, so it will return false. Sorry, my computer's a little slow right now. Overall, the code's pretty well organized, in my opinion. For my enhancements, I plan to expand the functionality by incorporating maybe a little more data and analytics component to provide kind of a deeper insight into the adoption trends. Maybe displaying a filtering of historical outcomes, seeing which dogs are adopted a little more. Maybe German Shepherds adopted a little more for rescue missions, or golden retrievers, um, golden retrievers, or Labrador retrievers. for the water breed. And then we could also implement kind of seeing what months are, you know, the trend to be the highest in terms of adoption numbers. Normally around the holidays, around this time, the adoption numbers are a little bit higher. Um, so that's something else we could look into, see what months are kind of the hottest months for adoption. The changes will primarily be implemented inside the shelter, animal shelter.py class by adding new methods that use MongoDB aggregation pipelines. For example, I could add a method named analyze adoptions that group records by breed, counts the number of animals adopted for each breed, and returns a ranked data set. Another method could be seasonal adoption trends. I can name it that. That could extract the months, like I said, for each adoption date, and group it by months. That way we could find out which months are the most popular. Both of these new functions they will return results, and we'll be using Python dictionaries and Panda data frames, so they could easily be plotted. Probably use Matplotlib. I believe that's what I've used already. If I'm not mistaken. Yeah, pandas and Plotly is what I'll be using for that. And that's it for this project. Alright, for my second project, I will be using my CPP project, my C++ project, that is for data structures and algorithms. The goal of this project was to design a command line program in C++ that manages the course information for a computer science advising team. The program needed to load course data from a file, store that course in an efficient data structure, which I use binary search tree, and provide users with features such as viewing all courses, and alphanumeric order, and displaying individual course details with prerequisites. So let's jump right in. Again, I'll be using a checklist given to us, and the first one is structure. I believe that it completely and correctly implemented the design. We loaded the CSV file and inserted it into a binary search tree with the insert function. Right here, actually the load courses file function to load courses from a CSV file into a binary search tree. So we load the course. Here's our ifs. And if for whatever reason it could not find the file, it cannot open the file, it will shoot us the error, could not open file. Otherwise, it will be reading line by line with this while loop the courses in alphanumeric order into the binary search tree. Does the code conform to any pertinent coding standards? I believe it does. The naming is pretty well structured, and it's pretty consistent, which makes it easy to read. Are there any leftover stubs? Can any code be replaced? Maybe some small opportunities for that to happen. CSV parsing currently uses string stream. Where is my string stream right here? It is acceptable, but for probably better parsing, quoted fields, commas inside quotes, Probably consider a small CSV library or implementing quoted field handling, but that's nothing major. Documentation. Is this code clearly and adequately documented with an easy to maintain commenting style? I feel like I did pretty well commenting on everything. The structure to hold course information. So this is our course identifiers, our titles, the list of prerequisites. Here's another data structure. Node structure for the binary search tree. I did everything that every line did within that one. Commented pretty well on my ifs and my else's. Commented on all my functions, say what they do. Prints, see what they do. The main function, I have that labeled right here with everything that it does. So I believe the documentation was done pretty well, as well as the variables, like I stated before. For example, where is it? Course, create a course object, course, that's a clear container. The node root. Where's my node root? Node root. Node root right here. That's a root pointer. It's pretty obvious. My prerequisites. My vector string prereqs. If I could find it, right here. I feel like that's pretty clear and concise. So I believe my variables are pretty done. I've done pretty well. Arithmetic, there is no arithmetics in this one. My loops and branches. I think did pretty well. You can see, hold on, let me make my screen a little brighter, help me out. There you go. For example, my while loops. I think this is the only project that I'm using for this, that I use the while loop. Right here, read each CSV file. So while get line, file line, string stream, SS line, string course number, course name, and prereq. So it'll get the course number, the course name, and the prereq. And then it'll put in the vector string prereqs. The first two values, the course number and course name. So it'll get the course number, then there's a comma, and the course name, and there's a comma. The remaining values will get the prereqs. This is another while loop, a nested while loop. And that'll insert the course into the binary search tree. So overall, I think my loops did pretty well on that. Now for the enhancements that I have planned, possibly plan to expand the functionality of my binary search tree course lookup application by adding improved search capabilities. By that, add a prerequisite chain viewer function. The purpose of that will be so currently the system lists the immediate prerequisites of a selected course, but it does not show how these prerequisites relate to earlier foundational courses. So the enhancements will add a function that recursively displays all prerequisite levels in order. So for example, showing that CS400 requires CS300, which requires CS200, which requires CS100. So I'll put that function possibly under the print course info, under the load courses. Probably write something like void print prerequisite chain with a node and a root node, a constant string variable called course number. The logic behind that will be to use a find course to locate each prerequisite. Something small and simple is project was nothing major. The only problem for me was C++, as in I'm not that well rounded in C++, so I had to do a lot of digging to code in C++. But yeah, third and final artifact for software engineering design. I chose my mobile architecture and programming project written in Java using the Android Studios app. This project was a little bit more difficult for me as although I'm a computer science major, I really concentrate on data analytics, data science, data engineering. So I do a lot of scripting in Python, and I'm very familiar with Java. But just the overall structure of an application, I didn't realize how complex it was. So this project was a little bit harder for me, but overall, I think I did pretty well. To begin, the going down the checklist, we'll go through structure. I thought the code correctly implemented the basic design requirements using login. With my login activity here, we're able to enter the username, the password. This is the button to log in. This is the button to create an account, just in case you don't have one, maybe for a new employee. And then we have adding new items, updating quantities. That would be in the inventory dashboard. Give me a second here. Why is it not going? There you go. Here we have our add item quantity, the buttons. Let's see here. This connects to the user interface components to their XML layout IDs. So the add item name, add item quantity. That also allows us to update quantities and remove items. So yeah, most of our stuff that we do is here in our inventory dashboard activity. Since they wanted to create one page for everything. While the structure is functional, it does create a situation where a lot of the responsibilities of the application are all bundled in this one class together. This means that the project could be harder to scale or maintain over time. This is probably the main reason I chose a MVVM architecture, which is the mode view model architecture. I'll talk a little bit later about that for my plan enhancement. In terms of formatting the style, I use consistent indentation and standard Java naming conventions with a camel case. Classes start with capital letters. No leftover test functions or any unused sample data or unreachable code. Everything has a purpose. You can see that here, 2 usages. Let's see. All this class, public class. You got 5 usages, 3 usages, 4 usages, 3 usages, 2 usages, 3 usages. So everything's used pretty well. Nothing wasted. No tech debt, as I like to say. My documentation, I believe I coded everything pretty well. Once again, I feel like the commenting and quoting and all that, I've become pretty well at doing it along the way. I feel like that's the best way to do it because I've done it where I have not commented right away what the function or the line or the if loop or the for loop or the while loop does right away, and I end up getting confused at what it does. So just commenting along as you're writing the code definitely helps. Variables, I believe I named my variables descriptively. They're pretty self-explanatory. Add item name, add item quantity, button, add item, so that's the add item button. The view inventory recycler, the open SMS notifications button. In case stock gets low, you need to send a message out. item list, database helper. Um, yeah, I feel like I did pretty well doing the variable names. Arithmetic is pretty simple. Arithmetic, just adding the inventory. So add, you know, primarily just incrementing or de-incrementing item quantities by adding or deleting them. I didn't need to compare any floating point numbers or perform operations with large magnitude differences. So it's kind of, let's just say it's like a small mom and pop shop, right? Nothing. It's not a major corporation. Now, a major corporation wouldn't use this application as is right now. So I feel like my arithmetic operations were done pretty well. My loops and branches. My menu system uses a while loop. I believe that's in the main activity. Request SMS permission. So let's say you don't have SMS permission. This if else will if user does not have SMS permission, activity compat dot request SMS permission. So you will be requesting the permission. Else, and if you already have SMS permission, so you don't have to. So let's say you fill out the form to request SMS permission, and you already have permission. The else will tell you that SMS permission has already been granted to this user. And again, if you don't have SMS permission and you get it, or if you don't get it, either way, it'll update the permission status. So I think my if else's have done pretty well. For my enhancements, like I said earlier, I really want to implement the mode view model architecture. The goal for this enhancement is to improve the application's maintainability, scalability, and clarity. Uh, let's say this small business wants to grow, or they are growing. The current format right now, where everything's in one class, it'll be hard to scale. So I will have to implement the MVVM architecture. The MVV architecture separates the responsibilities a little more clearly, making the application easier to update and debug. So for the first part of the enhancement, the model portion of the architecture, currently inventory data is stored using basic collections inside the main class. So I'll redo this by creating an inventory item model class that represents each item with attributes such as ID, name, quantity, and threshold. This class is going to make sure that the data is structured correctly and consistently and clearly across the program. Next, we'll do the view model layer. Right now, the user interface interacts directly with the data and the logic. After the view model layer, the user interface will instead call functions from view model, which in turn communicates with the repository or the database. This creates separation between how data is displayed and how it is processed. So the view model will also use live data, which is pretty cool. Obviously with a company that's growing, that would be great. So it's a reactive data container that automatically updates the user interface when the data changes. So there'll be no lag time. It's pretty cool. The third part will be the view layer, which is the activity class and any user interface components. In the current version, the activity both displays data and manages inventory logic, which is a little difficult to maintain and scale. So after doing this, the activity will only observe changes from live data and call the view model functions. So basically, step by step, create the inventory item class, move data operations into an inventory repository, and create inventory view model to manage logic and expose the live data. And then updating the activity to observe changes and remove direct data handling. So yeah, those are my 3 artifacts that I chose.